we looked at a couple things, right? We looked at applications of polynomial equations and sketching polynomials. I want to just look at a couple quick examples. So what about something like that? What if it asked you to sketch a graph of the following? Remember, there were two parts to our sketches here. There was, let's see, is that going to work for, yeah. There was the end behavior part and then the x-intercepts part, right? Okay, what's the end behavior going to look like on this one? Positive even, yeah. So we know end behavior is going to do that, don't we? Right? Because of this leading term, that's our end behavior. Okay, now to find the x-intercepts, what do we have to do? Okay, we're gonna have to factor it. And the reason we're going to have to factor it is because to find the x-intercepts, we're going to set the function equal to 0 and solve, right? Now think why that is. F of x is just a fancy name for what? Y, yeah. So we want to set at the x-intercepts, what is the y value or the y coordinate going to be at every x-intercept? 0, yeah, exactly. So I want to set y, f of x, which is just y, I want to set that equal to 0. And then I find out where that happens by asking the math gods. I solve an equation. I find out when does this function equal 0, right? When does f of x equal 0? So we just get something like this. We get the equation 2x squared plus 12x plus 16 equals 0. The solutions are going to be the x-intercepts. Okay, so but to find the solutions, we have to factor, don't we? So what do we always do first? Greatest common factor. Can I undistribute anything here? 2. Yeah, I can take out a 2. So if I take out a 2, what's left behind? X squared plus 6x plus 8. Yeah. Okay, and then because this is an equation, why don't I just divide each side by 2 and just get rid of that 2? Make sense? Right? Let's do that. So we'll divide each side by 2, get rid of that, and now we have a much easier equation to deal with. X squared plus 6x plus 8 equals 0. Okay? Well, how would I mean, that's just a basic trinomial. I want to try to factor that. How would I factor that one? Exactly, just magic numbers, right? That multiply to 8 and add to 6. Yeah, what are those numbers? 4 and 2. There you go. So we break this up into x plus 4 times x plus 2 equals 0, right? And by the zero product property, what are my solutions? There you go. Either x equals negative 4 or x equals negative 2. So where are my x-intercepts? Negative 4 and negative 2, because those were the places where my function equaled 0, right? Where y equals 0. The y coordinate is 0 on the x-intercepts. So now look what we've got. We've got at negative 4, at negative 2 and negative 4, I have x-intercepts, and my end behavior is up to the left and up to the right. So what's this thing doing? It's just doing that, isn't it? Make sense? Okay? All right, so then the other thing, I just want to remind you guys about the Pythagorean theorem. Okay? Look at maybe one application where we use the Pythagorean theorem. You guys know this from geometry, right? If you have a right triangle and you have legs of length A and B and a hypotenuse of length C, then A squared plus B squared equals C squared, right? Leg squared plus leg squared equals hypotenuse squared. Okay, so what if we have something like this? Find the length of the shorter leg of a right triangle if the longer leg is 10 miles more than the shorter leg, and the hypotenuse is 10 miles less than twice the shorter leg. Okay? So first of all, we know this is a right triangle thing, right? We're trying to understand the problem. We need to be able to maybe draw a picture of our right triangle. Which side of that triangle do we know nothing about? The shorter leg, right? We don't know anything about the shorter leg. We know a little something about the longer leg and the hypotenuse. So what should we set the length of the shorter leg equal to then if we know nothing about it? X. Yeah, the thing we know nothing about we'll set equal to our variable, right? So the length of the shorter leg, we'll call that X. Okay, well if X is the shorter leg, what's the length of the longer leg? What's it tell us about the longer leg? Longer leg is 10 miles more than the shorter leg. So what would it be? Say 10 plus X, is that what I heard? Okay, good. X plus 10 or 10 plus X, whatever you want to call it. Okay, so there's the longer leg. Now what about the hypotenuse? It tells us the hypotenuse is 10 miles less than twice the shorter leg. Well, what's twice the shorter leg? And then 10 less than that would be minus 10. 2x minus 10. I got to subtract 10 from that. Okay, good. Whoops. So there we go, right? The hypotenuse is 2x minus 10. And isn't that our right triangle then? Short leg is x, long leg is x plus 10. The hypotenuse is 2x minus 10. Everybody agree? Okay, good. So now how could I turn this whole thing into, I'm trying to solve for x, aren't I? Because if I knew what x was, I could plug that in and find out the length of every side of this triangle. Give me thumbs on that. Everybody understand? How could I come up with an equation then that's going to allow me to solve for x? Not exactly. What's the relationship here? The picture is very helpful. It's a right triangle. You got an idea? There you go, right? So this is like A, that's like B, and that's like C, isn't it? Right? So we could say x squared plus the quantity x plus 10 squared, leg squared plus leg squared equals hypotenuse squared. So it equals the quantity 2x minus 10 squared. Give me thumbs on that. Does that make sense? So we're just using the Pythagorean theorem here, right? Okay, good. Right? So that gives us that. Okay, well now we're just in math mode. We could just forget about the problem and go to work. So what would I do in this case to solve that equation? What's the first thing I'd probably have to do? I mean, kind of, I have to expand out, I have to multiply this stuff out, don't I? So I'd have to multiply out x plus 10 squared. Let's look at that for just a second. This one's a little tougher than the ones you're going to see on the assignment, but I want you to be able to kind of follow this logic. So how would I do that? I've got two strategies here. Say that again? Plus what? Okay, but I can't just distribute. Remember, this is stuff that's been a while since we talked about this. But I can't distribute an exponent when I'm adding or subtracting, only when I'm multiplying. So what's one way to do it? I saw the... Okay, so that's one way. I could just write this as x plus 10 times x plus 10, and I could FOIL it out, right? That's one way to do it. So if I were to FOIL this out then, if I distribute the x, I get x squared plus 10x. Now when I distribute the 10, I'd get another 10x plus 10 squared is 100, right? So x squared plus 20x plus 100, right? I can always do it that way. We have a pattern for this too, though, remember? What's our pattern for a plus b quantity squared? A squared plus Not b squared. What's in the middle? 2ab. There you go. A squared plus 2ab plus b squared. Now, our a is x and our b is 10, right? In this case. Agreed? If we use this pattern. So then wouldn't that just give us x squared plus 2 times x times 10 plus 10 squared? Either way, I'm going to get 20x in the middle. Everybody see that? Okay, so when we solve this then, whoops, first thing we're going to get is that part right there, right? X squared plus, when I expand out this whole thing, it gives me that, right? How about on the other side? 2x minus 10 squared. We have another pattern for that one. What's our pattern for a minus b squared? It's almost the same. What was it? A squared minus 2ab plus b squared. Only this time our a is 2x and our b is 10, right? Everybody see that? So that's going to give us, what would that give us then? That's going to give us, whoops, 2x quantity squared minus 2 times 2x times 10. 2 times a times b plus 10 squared. Well, what's that? 2x quantity squared is 4x squared, isn't it? Right there. Okay, look at these. Isn't that just giving us all this stuff? Minus 2 times 2x is 4x times 10 is 40x. Plus 10 squared is 100. Either way you do it. We could just either FOIL those out if we want to, or we can use these patterns. I think the patterns are way quicker and easier once you get used to them. But take your pick. Whoops. Either way, when I expand out, when I FOIL out the stuff that's being squared, that's what I get. So I could add up, everybody agree then I could add up the like terms on the left side and make that a 2x squared. Now what? What do I need to get on one side of this equation? 0. So where should I move everything? To the left or the right? I could, but I'm going to say the right. How come? What's the advantage of moving stuff to the right instead of the left? What is it? Yeah, and what's the one I'm really concerned about? I want my leading term. I want the number of x squared to be positive, right? Does that make sense? So I've got more x squareds on the right side than the left side, so we'll move everything over to the right side. So I'm going to subtract. I'm going to subtract 2x squared from both sides. I'm going to subtract 20x. And I'm going to subtract 100. So all this stuff cancels. And what do I get? 2x squared minus 60x. And look, that cancels. Everybody get that? Equals 0. How about if we put the 0 on the right side, though? Just to kind of make it look a little. So even though the 0 was on the left, let's flip it and put it on the right. Okay, give me thumbs so far. Does that all make sense? Right? This is just all the algebra that you guys know how to do. Now I've got an equation in standard form that I can solve. Well, what do I do? What do I always do? Greatest common factor. What could I undistribute from that? 2x. Yeah, if I undistributed 2x, 2x times x gives me 2x squared. 2x times negative 30 would give me my negative 60x. So that's what I get, right? My leftover would be x minus 30. Show me with your fingers. How many factors do I have on the left side now? 2. First one is 2x. Second one is x minus 30. So what are my solutions then by the zero product property? The only way I could multiply those two factors and get 0 is when I multiply by 0. So either the first factor has to be 0 or the second one does. What's the value of x that makes the first factor 0? Well, 2 times what is 0? 0. Yeah, okay, so one solution is x equals 0. Well, how about the next one? What's the value of x that would make the second factor, x minus 30, 0? Positive 30. So my solutions are x equals 0 or x equals 30, my mathematical solutions, right? Okay, but now we have to go back to the original problem and see if those make sense. Which one of those makes sense? 0 or 30? Which one of those doesn't make any sense? Remember, x is the length of the shorter leg. 0 doesn't make any sense, does it? If I have a leg in a triangle, a side of a triangle with length 0, is that even a triangle? No, right? That leg just completely disappears. So we could say that one, even though it makes sense mathematically when we did the algebra, in the context of our problem, that 0 doesn't make sense. So our answer is x equals 30, right? Are we done? Well, we're done with the algebra. What does that mean about the original problem then? If x equals 30, what does that tell us about our triangle? What's the length of this side? 30. What's the length of the longer leg? 40. Yeah, because I'm going to add 10 to that. What's the length of the hypotenuse? 2 times 30 minus 10. What would that be? 50, yeah. I'm going to get 60 minus 10, which is 50. Now I know the lengths of the sides of the triangle. Okay, make sense? And isn't that what they were asking for? What did they want? Find the length of the shorter leg. Okay, well, all they wanted was 30, I guess. The length of the shorter leg is 30. Okay? Give me thumbs. How we doing? Make sense? All right, you guys can go to work.